So this is question number 5. Alright, so what represents the impulse of a force in a graph of force versus time? Okay, so let's go through what the junior tutor answered here. Excuse me. The area under the force time graph represents impulse. So right away, this is kind of the correct answer, but they go on to explain is calculated as force multiplied by time. It is a vector and calculates the force that is applied over a particular time to an object. It acts only for a short time and can be used to find a change in momentum. This has several applications in automobile sports collision impact. So this is true. So let's look at a force versus time graph. So if we had some force here, time t, and then some force applied. So we could potentially have, like, let's say there's something like this. So this, let's say this is the plot that we're given, and we're asked to calculate the impulse of this situation here with this plot. So essentially what you'd have to do is figure out how to calculate the area here, and the area here, and that will give you the impulse. And the important thing to note here is the area is above the x-axis, so they're in the positive area of the y-axis. You would have positive values, but whenever you're above the x-axis, these would add to the impulse total sum, and then when you're below the x-axis, this area would be subtracted from the total. So if you had, let's say, let's call this I for impulse, and you had A, B, C, and you had A, B, C, you would do minus plus. So you'd add A, subtract B, and add C. So this is above, this is below, this is above, and that's how kind of the summation would work. And here you'd kind of, if they're just in triangle forms, you would just do the kind of the area of a triangle, half times base times height, and so on. So this is the correct answer. So correct answer. Great job. And we'll mark this as correct.